Hello my dear students, once again welcome to your online classes. Hope you had a great vacation. Now it's time to come back to your virtual classes again. So today in this video we'll be discussing about the 7th chapter of your physics textbook, that is the reflection of light. So in this chapter we'll be learning about the image formed by the two inclined mirror and then the spherical mirror. So in the reduced syllabus we just have only these two topics. But you must be knowing the basic of the reflection of light, that whenever a ray of light it falls on a smooth and plane reflecting surface, the ray of light turns back into the same medium, that is the bouncing back of the light is known as a reflection of light. So we have learned about the reflection of light from a plane mirror in class 8 as well. So today we will be learning about the image formed by the two inclined mirror. These cases you must have seen in case of a barber shop, where there is one mirror at the front and one at the back. Okay, so in that we see there are multiple images formed. Okay, so now if two of the mirrors are inclined in such a way, okay, that the angle between the two mirror is theta, okay, theta degree. Okay, so the number of images formed by these two inclined mirror is given by n is equals to 360 divided by theta. Okay. So this happens when the object is placed asymmetrically. Asymmetrically means it is not exactly between like the angle bisector. Okay, so if the image does not lie in the angle bisector, suppose if it is here or suppose if it is here B, so that is known as a asymmetrically. Okay, so if the object is placed asymmetrically, then the number of images formed is given by n is equals to 360 divided by theta. Now in case if it is placed symmetrically, that means the line or the angle bisector. Okay, so in the line this is the angle bisector, suppose here, that means at an equal distance from both the mirror, then the number of images formed is given by, suppose x is the number of images formed, then it is equals to n minus 1. So you just need to subtract one image. Okay, so now there are two special cases, that is when the mirror is parallel and the second is when the mirror is perpendicular. So when the two mirrors are parallel to one another, okay, so let us also draw the ray diagram. Okay, so the two mirrors, when the two mirrors are parallel to one another, then theta is equals to how much degree it is? 0 degree. Okay, so therefore the number of images formed. So in this case we consider when the image is placed symmetrically. Okay, so n will be equals to 360 divided by 0, which will be equals to infinity. And the number of images formed, that is the x will be equals to infinity minus 1, which will still be a infinity. Okay, so from a large number if you just take out 1, then the number will still be a larger one. Like for example from the ocean, if you take one glass of water, what happens? The ocean still remains the same. So the number of images formed when the two mirrors they are kept parallel to one another is infinite. Okay, so if you are asked to draw the ray diagram, draw object A. Okay, so it suffers a reflection from the first mirror. Okay, and then it gets reflected back here in the second. Okay, so the first image formed here will be here, I1. Okay, so this I1 will act as an object to the second mirror. So here, again from here it gets reflected back in this way. So again here the second image will be formed, I2. Okay, again it goes to the another mirror. So there again when you bring it back, you will see the another image, I3. So it goes on and on. Okay, so there are infinite number of images formed when the two mirrors are placed parallel to one another. Now coming to the second case, when the number of images formed when the two mirrors are kept perpendicular to one another. Okay, one mirror being here, the other mirror being there. Okay, here the angle, here it is 90 degree. So when theta is equals to 90 degree, what happens? So the number of images formed will be equals to, it is 360 divided by 90. So this is how much? It goes 4. So therefore the number of images formed will be equals to 4 minus 1, which is equals to 3. Now it's also important to remember that when the image is, so where will be the image formed? The image will be formed in the circumference of the circle. Okay, and the circle of that center will be the point of intersection of two mirror, and the radius will be taken the object distance. Suppose here it is O. Okay, here is the object. So I draw one radius here and then I draw a circle. Okay, all the images will be formed in the circumference of a circle. Okay, so let us try to draw the diagram. So the first two rays I make it incident here. Okay, then this gets reflected back. Okay, so it gets reflected back into the second mirror like this. Okay, and then the first image formed here will be like when you extend it backward. Okay, so the first image here, the I1 is formed. Now the second image, so this goes back again to the, okay, so the second image I make this come backward. So this is I2 image formed. The third image is directly formed on the opposite side of this mirror. Okay, here. So this is I3. So thus we see that the three distinct images will be seen when the two mirrors are kept perpendicular to one another. So now also one important topic here, so uses of the plane mirror, which we know it very well. So the plane mirror are used in a barber shop, it's used to create optical illusion, it's used as a reflector. Okay, so those are the things to be remembered here. Now the second topic is a spherical mirror, which I'll be adding up in this video. Reflection of light but through a spherical mirror. Now coming to the term spherical mirror, what is a spherical mirror? A spherical mirror is a part of a big hollow sphere. Okay, and that a part of that hollow sphere, it acts as a reflecting surface. We already know a plane mirror is the one which is straight. A smooth reflecting surface is known as a plane mirror. But if that smooth mirror is curved inward or outward, then it forms a spherical mirror. So the spherical mirror are two kind. The one is the concave and the other is a convex. Okay, so we have two kind of spherical mirror, a concave and a convex. What is a concave now? Now that a part of a hollow sphere, okay, if the outer part is painted and the hollow part is the reflecting one, then it is known as a concave mirror. And what is a convex? In case of a convex spherical mirror, the hollow part is painted, and whereas the bulged surface is the reflecting surface. Okay, so that is the basic difference between a concave and a convex mirror. Now coming to both of these mirror, we can complete this arc to form a bigger sphere. Okay, so here also, in this case also, so both the ways I can make a complete sphere. Now there are some terms related to both the spherical mirror. So the first one being the center of curvature. Center of curvature. Okay, so what is the center of curvature? The center of curvature is the center of that hollow sphere whose part is a mirror. So if I have here the center of the sphere C, here also I have the center of the sphere C. So this point is known as the center of curvature. The second we have is the radius of curvature. Radius of curvature is nothing special but the radius of the sphere whose part is a mirror is known as the radius of curvature. Okay, then we have a principal axis. So what is the principal axis? The principal axis is a straight line that joins, before that we must know pole also. Okay, so what is a pole now? The geometrical center of this mirror is known as a pole. Okay, so I write here P, and a straight line connecting the pole and the center of curvature is known as a principal axis. Okay, so what is a principal axis now? The principal axis is a straight line that connects the pole and the center of curvature. Then we have focus. Okay, so another term we have is the focus. Now what is a focus? A focus is a point somewhere on a principal axis such that any ray coming parallel to the, coming parallel to the principal axis, after reflection it passes from that point. In case of a concave mirror and in case of a convex mirror, it appears to come from that point. So that point is known as a focus. Okay, so the focus lie exactly in the halfway of the pole and the center of curvature. Okay, so like in this case, okay, if this is a pole and if this is a focus, if any ray is coming parallel to the principal axis, after reflection it will pass through the focus. And in this case, like if I have to draw the ray diagram, any ray, okay, which is going parallel to the principal axis, after reflection it will appear as if it is coming from the focus. Okay, so it will go in this point. If you extend it backward, it will appear as if that ray was coming from the focus. So these are some of the basic terms you must understand related to the spherical mirror. Now we shall draw the ray diagram formed by a concave mirror and a convex mirror. But before that, you must remember few of the rules to draw the ray diagram. Now there are some of the basic rules that must be followed in order to obtain the image formed by the concave and a convex mirrors. Okay, so the rule number one is, suppose I draw for a concave mirror. Okay, so this is the principal axis, this is the center of curvature, this one is the focus and this one is the pole. So if the rule number 1 says that if any ray is coming parallel to the principal axis, after reflection it will pass through the focus. So that is the first rule you must remember. The second one is, if any ray, suppose this is the focus, this one is the center of curvature, this one is the pole. If any ray is passing through the focus, after reflection it will emerge parallel to the principal axis. And the third one is, if any ray is incident at the pole, okay, so it will get reflected back in the same way with the angle of incident I equal to the angle of reflection R. So the same may be followed in case of a convex mirror as well. Okay, so in case of a convex mirror, okay, so if any ray is coming parallel to the principal axis, it will appear as if it was coming from the focus. Okay, so this will appear as if it was coming from the focus. Second one is, if any ray is moving towards the focus, okay, so like this is going towards the focus. So after reflection it will emerge parallel to the principal axis. And the third one is the same only. Okay, here if any ray is incident at the pole, it will get reflected back with the same angle of incidence. Okay, so these are the three rules to draw the ray diagram in case of a concave lens and in case of a convex lens. Once again I will tell you, if any ray is parallel to the principal axis, it will pass through the focus. If any ray is passing through the focus, it will emerge parallel to the principal axis. If the incident ray is incident at the pole, then the angle of incident will be equal to the angle of reflection. And in this case, if any ray is going parallel to the principal axis, after reflection it will appear as if it was coming from the focus. Second one, if any ray is parallel to the principal axis, it will get reflected back as if it was coming from the focus. Okay. Oh no, sorry, it's if any ray is going towards the focus, it will get reflected as if it is parallel to the principal axis. And the third one is, if it is incident at the pole, the angle of incident will be equal to the angle of reflection. So following these 6 rules to draw the ray diagram, you can draw the formation of image by a concave and a convex mirror for any position of the object. So let us first see for a concave mirror. So here I have drawn the 6 cases. Okay, we will be drawing the 6 cases when the position of the object is at a different distance from the mirror. So the first one, let us consider the object is at infinity. Okay, at an infinite distance. Okay, so object at infinite distance. So when it is at infinite distance, all the rays come parallel to the principal axis. Okay, so the rule tells us that if any ray is parallel to the principal axis, after reflection it will pass through the focus. Okay, so in this way. So what happens when the object is at infinity, the image is formed at focus, and the nature of the image is it is always inverted or diminished to a point, and also a real image because it can be obtained on a screen. Now the second one, I bring the object closer, that means I will keep it beyond the center of curvature. So again I draw 2 rays, one coming parallel to the principal axis, another passing through the focus. Okay, so the one that is parallel, it will pass through the focus, and one that is passing through the focus will emerge parallel to the principal axis. So we see that the image will be formed between C and F. Okay, the image is inverted, the size of the image will be smaller than the object, and the image will be a real. Now another case, when I keep a ray of light exactly at the center of curvature. Okay, so I will draw the 2 rays, one parallel, another passing to the focus. So one parallel will pass through the focus, another will go parallel to the principal axis. Okay, so we see that when the object is at center of curvature, the image will also be formed at center of curvature. The image is inverted, same size and real. Now I will bring it more closer. I will keep between C and F. So again 2 rays, one parallel, another passing to the focus. Okay, the parallel one will pass through the focus, and this one will go parallel to the principal axis. Okay, we see that when the object is between F and C, the image is formed beyond the center of curvature, and the size of the image will be the larger one. Now coming to the another, when the object is at focus, one ray I draw parallel. Now I cannot draw another ray passing through the focus. Okay, so I will draw another ray incident at the pole. So the one that is parallel, it will pass through the focus, and this one it will follow the same. If it is I, it will get reflected with the same angle R. Okay, so these 2 rays are almost parallel, and it's assumed that it meets at an infinite distance. Okay, when the object is at focus, the image is formed at infinity, and the size of the image will be very large compared to the size of the image will be very large compared to the size of the object. Now finally, when we keep the object between the focus and the pole, okay, one I draw parallel, another incident at the pole. So the parallel, it will pass through the focus, and pole, it will get reflected. So we see that this is the diverging ray. In case of a diverging ray, they will never meet at any point. So the image is obtained by extending the reflected rays backward. Okay, so this is only the case when we obtain the erect image by a concave mirror, and also the image is a virtual image. Okay, out of all of this, the sixth ray diagram is very important from the examination point of view. You may be asked to draw the ray diagram when a concave mirror forms a virtual and as well as a erect image. So these six are the ray diagram formed by a concave mirror. Okay, now for a convex mirror, we have only two of the ray diagrams. The first one, the image at infinity, and the second one, the image at any point on a principal axis. So now coming to the convex mirror, so first we consider the case when the object is at infinite distance. So at an infinite distance, all the rays will come parallel. So we know that in case of a convex lens, when the rays are parallel to the principal axis, after reflection it will appear as if it is coming from the focus. So this is the focus, so it will appear as if it is coming from the focus. Okay, and then what happens? So to obtain the image, I extend this reflected rays backward here. Okay, so now when the object is at infinity, okay, the image is formed at focus, and the image is a virtual image, and the image is also the diminished image. So the second case is when the object is at any point on a principal axis. I draw two rays, one parallel, another incident at the pole. Okay, so this will get reflected back in this manner, and the one that is parallel to the principal axis, it will appear as if it was coming from the focus. So it will go in this straight line. So the image will be obtained by extending these two reflected rays backward. Okay, so I'll extend this backward and here also. Okay, so the image is formed here. So now for a convex lens, whatever may be the position of the object, the image will always be formed between the pole and the focus, and the image will always be smaller than the size of the object, and the image will be erect and as well as virtual. Okay, so it is very important for you to remember all the ray diagrams or the rules to draw the ray diagrams to obtain the image formed by a convex and a concave mirror for different position of the object. Now finally, coming to the last topic of this portion, we have the uses of concave and a convex mirror. So these mirrors may be used to create an optical illusion. They are used in telescope, they are used in binoculars. Okay, so there are various uses of a concave and a convex mirror. You can go through your book. So this is the end of the chapter.